The next thing we're going to look at is the relationship between U and H. How are internal energy and enthalpy interrelated? If we know one, we can calculate the other. And that relationship I'm going to show you, starting with the basic relationship for enthalpy. We know that enthalpy is related to delta U by the following equation. The change in enthalpy equals the change in internal energy plus P delta V. If we want to be able to relate these two values for PV work, pressure volume work, for an ideal gas, then we can take what we know about the relationship between the pressure and volume for an ideal gas and substitute. PV equals nRT, so therefore P delta V, the only thing in this equation that will change, and that's not constant, would be delta T on the other side. So therefore we will substitute this value for P delta V. So therefore delta H is equal to delta U plus NR delta T, and that's our relationship. If we want to be able to solve for the internal energy or the enthalpy, only knowing how many moles we have, our gas constant value, which of course we're using for energy to be 8.314 joules per Kelvin mole, and our temperature. If we know these three things, then we can relate the value of delta U to delta H. So therefore, to calculate delta U from delta H, we would simply rearrange the equation to make that relationship. We can take this relationship one step further, and I'll show you that on the next page. But before I do, I just want to reiterate this equation is one for us to remember, because if we know either delta H or delta U, then we can find the other. Taking this relationship that we just found, delta H is equal to delta U plus NR delta T, and rearranging where we have delta H and delta U on the same side, we can derive another expression or another relationship by dividing both sides by N delta T. If we do that, we can simplify this equation like that. So knowing what we know about the value of delta H divided by N and delta U divided by N, these are molar quantities. The delta H divided by N is the same thing as the molar enthalpy divided by delta T. And the delta U divided by N is the same thing as the molar internal energy, or internal energy per mole, divided by delta T. And this equals to R. Now if you go back to our previous video where I showed you the relationship among Q, the heat capacity at constant pressure, enthalpy, and internal energy values, you will see that the Molar enthalpy divided by delta T is the same thing as the constant pressure heat capacity per mole. And the internal energy per mole divided by delta T is the same thing as the constant volume molar heat capacity. And so basically, if we know either, this gives us a final relationship, and if we know either the constant volume molar heat capacity or the constant pressure molar heat capacity, because we know the value of R, if we know one of those values, we can solve for the other. And remember, once again, that the value of R is 8.314 joules per Kelvin mole. The last relationship or equation that we want to discuss in the chapter or in this unit is the relationship or how to measure heat for a perfect gas. Because we know delta U is equal to Q plus W, and in an isolated system, delta U is equal to 0, then therefore Q will be equal to negative W. If we know that W for a perfect gas, and we are talking about isothermal reversible expansion or compression, these are the keys. We're talking about isothermal reversible expansion or compression. We know that W for an isothermal reversible expansion or compression is equal to negative nRT, natural log of V final over V initial. So if Q is equal to the negative of that, we have Q being equal to positive nRT, natural log of V final over V initial. So that's the last equation that we're going to talk about. And so we're not going to look at an example of this equation because it's simply the same type of example that we saw when we calculated work for a isothermal reversible expansion, except we just take the opposite sign. So what we are going to do though Now, what you should do is go back through and make sure that you have a recap of all of your equations from this unit, and make sure you do that in one convenient place so that when we start working more example problems, you'll have a way to conveniently refer back to your key equations.